So in this lecture, we're going to talk about putting together seed mixes. Some of the considerations that you need to take into account. You can go to the seed dealer, and those guys are very helpful. But you also have to remember that they're in the business of selling you seed, and sometimes they like to sell you what they have, and they like to mix other things in there that you may really not need or want. So in this lecture, we're going to kind of talk about some of the things you want to consider, and to help you make an informed decision when you go to to buy the seed and plant different mixes for different goals and objectives. So some of the things to consider. One of the big things is cool versus warm season grasses. Many people have the perception that it's a good idea to mix the two together. And in the native situation and native range situation, you're going to find the two mixed together. But in a more productive, irrigated pasture, improved pasture type situation, it just really complicates your overall management. It seems to make sense that you can maybe even out that forage productivity curve over the growing season by mixing the cool seasons that come on in the spring and are highly productive in the spring. And you have some warm seasons that come on in that mid part of the summer, and then those cool seasons come back on and produce in the fall time period. But basically what happens is those cool seasons come up fast. They overshadow those warm seasons and basically provide competition against those warm seasons, and a lot of times the warm seasons just never are very productive in the end. So if you want cool and warm season pastures, it's best to have them separate, and typically I recommend maybe about 75% of your pasture area be in cool season and about 25% in warm season type species. And again, that will help you kind of even out that forage productivity curve over the season. Again, it's just difficult to manage. There's just differences in palatability among the warm and the cool season. The cool season are just going to be a lot more palatable, so they tend to be overgrazed sometimes. And so just a lot of reasons why you don't really want to mix these two together. The next thing you really want to consider is the bunch versus the sod forming grasses. And typically I like to mix the two together. It's not a necessity, but again, there's some reasons for doing that. Those bunch grasses tend to be more productive, but the sod formers, those rhizomes or stolons, can fill in those bare spots, and especially in pastures that are going to be grazed. You're going to have areas, like say close to the water, areas where you're going to have trailing by the animals. You have maybe some winter kill of some of the orchard grass, for an example. If you have, say, something like smooth brome in there, with the rhizomes, it can fill in some of those bare areas and keep, a nice tight sod that's not susceptible to erosion, etc. Things to consider are, again, some of the bunch grasses are not conducive to haying. Things like the Russian wild rye, crested wheatgrass, sometimes those kind of become kind of pedestaled or bunchy. Makes a very rough field to get equipment over. On the other hand, some of the sod formers can become somewhat aggressive. Things like the creeping meadow foxtail, the smooth brome can actually, spread quite a distance and basically kind of outcompete some of the other species at times, either the bunch grasses or if you may have some of the legumes in the mix. Other things to consider are the intended uses of the particular field that you're going to be planting. Are you going to be haying it, grazing it, or are you going to be using it for both? Again, some species are better suited for haying. Examples would be like intermediate wheatgrass, timothy, or pubescent wheatgrass would be another one that would be better suited for haying. They just don't have the regrowth potential that things like orchard grass might have. Some species are better suited for grazing, things like Kentucky bluegrass, your shorter stature, shorter growing type species. Perennial ryegrass would be another one that is probably better suited for grazing compared to haying. Your white clover, again, just puts those little petioles up with those 3 leaflets on the top. Just never gets very tall. Not really tall enough to be economically useful for haying. Then you have your dual purpose type species, and that's why a lot of times when you go to the seed dealer and they're going to have an irrigated pasture mix that's going to be suitable for both haying and grazing. And those are going to contain things like your orchard grass and your meadow brome and sometimes smooth brome will be the 3 species that will be consistently in some of these irrigated pasture mixes. Palatability. It's another big consideration. You don't want to mix species together that have wide differences in palatability. Orchard grass versus intermediate wheatgrass. They grow fine together, but the intermediate compared to the orchard grass is just not as palatable. And that's why many times I recommend that intermediate be planted as a monoculture by itself. It's highly productive. Animals will graze it, but if there's anything else in the pasture, they tend to graze it first. Meadow brome, another example would be like meadow brome versus some of the tall fescue, especially the older tall fescue varieties. They're always going to take that meadow brome over the tall fescue. Now there has been some work in recent years on tall fescue to develop a finer leafed, more palatable type, grazing type tall fescue. So if you're really looking to graze tall fescue, you might want to really do some research into some of those newer varieties. Height of growth would be another thing to consider. You don't want to mix some of your short and tall species together, especially in the hay mixes. Those taller species are going to basically shade out those shorter species, and those short species will disappear from the composition. Things like, Kentucky bluegrass is better suited for grazing than haying. That's one that tends to kind of be shaded out when it's growing, say, with smooth brome or something like that. Another consideration is the rate of recovery after haying or grazing. There can be some wide differences among some of these species. Species like orchard grass and meadow brome have a very quick recovery rate. Perennial ryegrass would be another one that has a very quick recovery rate versus things like smooth brome and timothy. For hay harvest, you can typically harvest things like the orchard grass and meadow brome, at least in Colorado and the environment here, 3 times versus smooth brome. You're probably only going to harvest that one twice if it was growing side by side in the same field. Sometimes it is okay to mix maybe some of these species that have different regrowth rates. Probably the best example is the orchard grass meadow brome mixed with smooth brome. Smooth brome is put in the mix because it's rhizomatous. It's going to fill in those bare areas, but it also provides very early spring growth, so it's going to really add to the tonnage as well as palatability of that first harvest in the spring. It'll kind of go dormant during that late June, July time period, and then in that third harvest, you'll see the smooth brome come back and be a fairly good mix with the orchard grass and meadow brome. So that is a very common 3-way mix for irrigated pasture hay production. Further things to consider. Drought tolerance. Definitely need to consider that when you're dealing with dry land or limited irrigation situations. Orchard grass may not be the best species in those types of situations. Most of your wheat grasses, wild rye, your warm season grasses, possibly sainfoin, and alfalfa. Again, alfalfa is one of those highly adaptable, very versatile type species that can grow in both dry land as well as fully irrigated situations. So it may be one that you want to include in a mix with some of these limited irrigation dry land type species. Salt tolerance is another big consideration. If you're dealing with soil, especially in the west, Colorado, we have, and in other parts of the West, we have these salty, saline, alkaline type soils, and there's only certain species. If the salt content gets too high, there are only certain species that are adapted to those conditions. You need to test both your water as well as your soil, because a lot of our irrigation water also carries a lot of salts that's added back to the system and can affect plant growth. Again, as far as salt tolerance, most of your wheat grasses and wild rye will at least have a moderate tolerance to salty soils. Tall fescue kind of has a moderate or medium tolerance as well. Creeping meadow foxtail has fair tolerance to salts. And strawberry clover is one that we don't utilize very much, but I have recommended it in some situations for someone that wanted a legume. It's not a very productive legume, but it will add some nitrogen back to the system, and would probably be a legume that would be utilized more in a grazing situation than a hay situation, because it is fairly low growing, but it has pretty good salt tolerance. Probably the most salt tolerant species that we have is tall wheatgrass. Again, it's not the most palatable forage species, but is the most salt tolerant. Probably a better option is the hybrid, the new high hybrid wheatgrass. It's not far behind as far as salt tolerance, but it has a lot better palatability, regrowth potential compared to the tall wheatgrass. Winter hardiness. Again, in the west, in Colorado, on higher elevations here in the west, winter hardiness is always a consideration, even at the lower elevations where we get those dry, open, cold winters. We can have winter kill type problems. Again, meadow brome compared to the orchard grass would be a better choice if you're in an area where you might have problems with potential winter kill. There are some specialty species out there that are very tolerant to high water tables or periodic flooding. Creeping meadow foxtail can withstand up to 60 days of total soil inundation, 2 to 3 inches of water on the soil. Again, has that mechanism within the roots that it can actually extract oxygen out of the water through the root system. Reed canary grass is grown quite a bit in the eastern U.S. for pasture and hay production. It grows here in the west, but primarily along like irrigation ditches, canals, rivers, and streams. Again, where you have very saturated wet soil conditions. Timothy is actually fairly wet tolerance, not quite as tolerant as like the creeping meadow foxtail, but if the water table is within 6 inches a foot, Timothy will survive under those types of conditions. So again, it's one that works very well in these high elevation mountain meadows that have that kind of more of that wild flood irrigation type system. As far as legumes, Alsike clover, in my experience anyway, is one of the most wet tolerant legumes. I often plant Alsike and mammoth red clover together in the high elevation mountain meadows, and I've seen as little as a 2 to 3 inch difference in the soil height or height of the soil surface and topography. The Alsike will be growing down in maybe a small depression, whereas the red clover is growing up on the edge of that depression where it has just a little more drainage to the soil. So those are some of the considerations for when you're thinking about putting together some of these seed mixes. So when you get to the actual point of putting the mix together, again, for these irrigated pasture, improved pasture, or hay production situations, you want to keep the mixes simple. Generally no more than 3 or 4 grasses at the most, and each of those should have a purpose in the mix. And if you want, you can add a legume to the mix, and generally only 1 legume. Again, there are some exceptions to some of these general rules. But say, that common irrigated pasture mix with orchard grass, meadow brome, and smooth brome in it. Orchard grass is very productive. It suffers the least from that summer slump during that hot time of the summer. Tends to grow as long as it has water. Meadow brome is another bunch grass. Grows more drought tolerant, more winter hardy, has regrowth potential almost as good as orchard grass, not quite. And then the smooth brome, is going to help to fill in if you do happen to have any winter kill problems or whatever with the orchard grass. Plus, it provides that early spring growth that really adds to your tonnage in that first harvest or first grazing. When you're talking about legumes, like I say, I do tend to, one exception, I tend to mix the Alsike and the red clover together in those high elevation mountain meadows because of the slight difference in site adaptability of those two species to the different saturation levels of the soil. If you anticipate a weed problem, you're always going to have a few weeds. Anytime you seed a new field, you're going to have some weeds. If it's the field is going to be pretty weedy, you may want to leave the legume out, and allows you to use some type of a broadleaf herbicide to get the weeds under control, and then at a later time you can come back in and actually interseed the legume back into that grass hayfield. When you're looking to buy seed, you actually go out and you buy some seed, there's a lot of good information that you can find on the seed tag. And this is just an example of a seed tag. Some of the more important information, you're going to get the variety as well as the species of that variety, or you're going to get the species as well as the variety of that species is going to be listed. Some of the more important information is whether it has any noxious weed seed that was found in that, and what the germination rate is, how much of that seed is actually going to germinate, and the purity. There's always going to be impurities in the seed, in that bag of seed. Could be sticks, dirt, chaff, a number of different things that you can find in there. But the purity and germination are two of the things that you really need to look at. That's going to tell you basically the quality of the seed that you're buying. So the purity and germination go together and we can calculate what's called the pure live seed. So you buy a 50-pound bag of seed, only a certain percent of that is going to germinate, and only a certain percent of that is going to be pure. Okay, so by multiplying those two values together, we can calculate what's called a pure live seed. Which is again a measure of your seed quality. So, if only 50% of that bag of seed has the potential to germinate and produce a plant, that's a pretty poor quality bag of seed. But you will find that many times on especially some of these native type species where the germination and maybe the purity or the ability to clean that seed is not very good. So the percent PLS, or pure live seed, is nothing more than multiplying the percent purity by the percent germination and dividing by 100. As an example, we have here on the seed tag purity of 90% and a germination of 95%. Multiply the 90 by the 95%, divide by 100. So the pure live seed in that bag is 85.5%. So basically a little over 85% of the seed in that bag has the potential to actually produce a new plant. Okay, so 15% is basically either seed that was not mature at time of harvest, is not going to germinate, or it's some of that junk type other seed, chaff, sticks, those types of things that might be in that bag. So when you go to buy seed, comparing seed is generally sold when you go to buy seed, you want to compare it on a pure live seed basis. Most seed is sold on a bulk pound basis. Not all seed. Some of the native seed is sold on a pure live seed basis. So they've already calculated that germination and purity into the price of the seed. But here's an example of alfalfa seed where dealer A is selling alfalfa at $3.50 a pound, whereas dealer B is selling the exact same variety of alfalfa at $3.25 a pound. You may think that dealer B has the best value, but does he really? The purity on dealer A is 99.5% with a germination of 90%, whereas dealer B purity is only 90% and the germination is 85%. So we calculate out the pure live seed of dealer A, and it's 89, a little over 89.5% of the seed in the bag, again, would actually produce a new plant. Whereas on dealer B, only 76.5% of the seed in the bag would actually produce, has the potential to produce a new plant. So how do we figure out, who has the better deal? We take that pure live seed value and divide that $3.50, that's our bulk cost, our selling price of the seed, by the decimal fraction, 0.8955, and that says that the actual cost of the seed is $3.91 pure live seed pound in that bag. Whereas dealer B, we divide the $3.25 by the 0.7650, and in actuality, the seed is costing us $4.25 a pure live seed pound. So who has the better deal? Dealer A, even though on a bulk basis it is costing you more, but you have the potential to actually get more total plants out of that bag of seed from dealer A. So if you think about this, if you're buying a 50-pound bag, the difference on a PLS basis is 34 cents a pound or $17 a bag. Okay, so economically, you're going to have to buy less total bags of seed from dealer A compared to dealer B to get the same amount of total live seed, is what we're saying there. So the PLS is also used in helping determine our seeding rates, our bulk seeding rates. Because when you go to the charts, either the internet or charts in a book, and get a seeding rate, recommended seeding rate, it is generally expressed on a pure live seed basis. Okay, so again, you need to account for the germination and purity in that particular lot of seed that you're buying. So it's going to help you to calibrate your broadcast spreader or your drill or whatever to determine again how much bulk seed that you need to be planting per acre. So really what you need to do is just you divide, if it's your recommended pure live seed pounds per acre by that percent PLS, and again use the decimal fraction of the pure live seed. So here's an example. We have a recommended PLS seeding rate for crested wheatgrass of 7 pounds per acre. So the PLS on that lot is 90% purity and 88% germination. So that gives us a PLS of 79.2%. Divide that 7 pounds per acre by the 0.792, and that says we need to seed 8.84 pounds per acre of that bulk seed in order to get 7 pounds of seed that will actually germinate out there. Okay, so you need to also take this into account when you're buying seed. And again, the lower the quality of the seed, the lower the germination, the lower the purity, the more total bulk seed you're going to have to buy to achieve that pure live seed seeding rate. So when we're dealing with these forages, seed size varies quite a bit, so how do you know if you're seeding, putting out enough total seeds per acre, to get a good stand of seed? So here's some general guidelines for drill seeding under irrigated conditions. So the number, it's based on the number of pure live seeds per square foot that you're planting out there. So for large seeds, what they consider large seeds is seed size under 65,000 seeds per pound. So you need about 20 seeds per square foot, pure live seeds per square foot, for those very large seeds. For medium seeds, and this is where a lot of your forages will fall, is between the 65,000 and 500,000 seeds per pound. And you need about 40 seeds per square foot. For the small seeds, 50,000 to 1,000,000 seeds per pound, 60 seeds per square foot. And for those very small seeds that are over 1,000,000 seeds per pound, things like Timothy, Kentucky bluegrass, those type. You need 80 small seeds or 80 seeds per square foot. So why do we increase the number of seeds per square foot as the seed size becomes smaller? Because as the seed size becomes smaller, there is less energy in that seed, and so fewer of those seeds will actually survive and produce a new plant. So we have to compensate for a higher death loss in those seedlings because they're going to have a lower seedling vigor due to that less energy contained in the seed. So these values that I just gave you, for if you're under dry land conditions, you need to divide those values in half. Again, you have less moisture, soil moisture available, so you don't want to be putting too many seeds out there so you have too much competition among those new seedlings as they come up. Now, if you're dealing with a broadcast situation where you're just broadcasting the seed out on top of the ground and not drilling it, then you want, so those are going to be some of your more poor seedbed conditions. You're going to have poor seed to soil contact. So typical recommendation is to double the seeding rate. So you want to double those values that I gave you up above. It's hard to get, some of the seeds are going to be left on the surface. Some of them, if you try to harrow it or something after you broadcast the seed, some of the seed might become too deep. So to compensate for some of that, we put out more total pounds of seed per acre. Now there's also what's called a Brillion type seeder, which is kind of a modified broadcasting, kind of a modification between broadcasting the seed and drilling the seed. And so the typical recommendation is to increase the seeding rate by 1.5 times those values I gave up above. And here's just an example of kind of how a Brillion seeder just has two big gangs of heavy rollers. The first roller kind of firms and prepares the seed bed. The seed is dropped, basically just broadcast out of a box behind that big set of rollers, and it has a smaller set of rollers that presses the seed into the soil to get that seed to soil contact, which is critical for proper germination and establishment of these new plants. So here's just some examples of some different forages and the number of seeds, average number of seeds per pound, and the recommended seeding rate in pure live seed per acre, and what that calculates out to in the number of seeds per square foot. That relates back to those general guidelines I just gave you. As you can see, the seed size varies considerably among these perennial forages. In this example, we have meadow brome has about 80,000 seeds per pound, whereas Timothy has 1.3 million seeds per pound. So that meadow brome would fall into that kind of that medium category, whereas the Timothy would fall into that very small seed category, so where you need to increase or have a larger number of actual seeds per square foot. And where you can see where we calculated that out. The meadow brome, around 28 seeds per square foot at 15 pounds pure live seed per acre, whereas on the Timothy, it's around 90 seeds per square foot, but you're only seeding about 3 pounds of pure live seed per acre. So again, this just kind of gives you some examples of how seed size, seeding rates, and number of seeds that you're actually planting, recommended number of seeds that you're planting out there per square foot varies among these different species. So in this example, the average number of seeds per pound is determined by dividing the total number of seeds per acre by the total number of pounds per acre that you're going to be seeding. So that gives you 223,000 seeds per pound that you're going to be seeding. You go back to your chart, and that kind of falls into that medium category, which is approximately 40 seeds per square foot. We're seeding 50. Maybe just a few more than we need, but still not an unreasonable seeding rate. If it falls between the 40 and the next highest recommendation of 60, if it falls somewhere in between that range, I consider that to be an all right or acceptable seeding rate. We're not really overseeding or underseeding these different species for this particular mix. Other ways to think about, you can think about not just seeds per square foot, but you can think about seeds per linear foot of row, seeds per inch of row. Those are just different ways to kind of visualize, the number of plants that potentially you're going to have with this particular mix. With most drills, there's going to be at least 2 rows per square foot, so 2 linear feet of row when you're drilling. So 51 seeds per square foot divided by 2, you're going to have just a little over 25 seeds per foot of row. Or if you're going to divide that by 24 inches, you're going to have basically 2 seeds per inch of row. So think about, once those plants mature, part of those plants are going to die and not make it to maturity. Can you live with, 2 mature plants, again, accepting some death loss in between per inch of row. Again, that just again gives you another way to visually kind of think about this, and are you overseeding or you're underseeding? If we lose a few of these plants, will we still have enough there once those plants mature to make a full productive stand? And again, in this situation, this would be an acceptable seeding rate, no matter which way you look at it. So again, you need to think about, use your PLS, that percent germination, percent purity, to determine bulk seeding rates. Again, for this particular mix, I gave you the percent purity and percent germination for each one of those species in the mix. Calculate the percent PLS, as I showed you earlier, and we calculate up the percent or pounds of pure live seed for each species in the mix from the earlier chart. And then we just divide that by your percent PLS. Tells us how many pounds of bulk seed for each species we need to be included in the mix. So about 10 pounds of pure live seed per acre, about 12.4 pounds of bulk seed per acre. So again, you need to take this into account when you're buying the seed. Okay, make sure you get enough seed so you get that, seeds out there that will actually germinate. So there are some reasons for adjusting some of these seeding rates, higher or lower from that chart that I gave you. Soil type is one thing to consider. Lower rates can be used on some of the light, sandy type soils compared to the heavier soils that contain more silts and clays. Why is that? Sandy soils do not crust. Once those clay soils get wet and then they dry out, that surface dries out, it tends to crust, and it's very difficult for many of these small seeded perennial forages to push through that crust. It's not like an oat seed or a wheat seed or something that has a lot of energy that can push through that crust. So we tend to increase the seeding rates a little bit on some of those heavier textured soils to account for some of that death loss that we know is going to happen due to the crusting of the soil. Seedbed condition and seeding method. Lower rates can be used when seeding into well-prepared seed beds, and in another lecture we'll talk about what those should look like. Lower rates can also be used when we drill versus broadcast, and I've talked about that a little bit already. Broadcasting, we just don't get that good seed to soil coverage, so we try to account for that by increasing the seeding rate a little bit. The small seeded species or species with low seedling vigor. Things like the Timothy and the Kentucky bluegrass, very small seeds, so we tend to increase the seeding rate, at least based on the number of seeds per square foot that we're putting out there. Things like bird's foot trefoil that have low seedling vigor. We tend to, again, increase the seeding rate a little bit because we know that a certain percent or a higher percent of those plants, seedlings are not going to make it to maturity. Okay, so we compensate for that. Use higher rates when we have heavy weed pressure. Weed competition is always a problem when we're seeding these perennial species, and we know the higher the weed pressure, the more competition, the fewer of those seedlings that are actually going to make it. So again, we compensate by increasing the seeding rate. And this is the last one here is kind of personal preference. Sometimes we increase the seeding rate so we can possibly increase that first year yields, knowing that over time, those due to competition, those plants are going to thin themselves out based on the available, area, soil, nutrient resources, water availability, those types of things. But I know in places like New Zealand and Australia, they do tend to use fairly high seeding rates, 40 pounds, 50, 60 pounds sometimes per acre of some of these cool season grasses in that first year to get a really nice thick stand. Again, realizing that some of those plants are not going to make it, or a big percent of those plants are not going to make it to maturity in the long term. But it does give them very good soil coverage and maybe some increased productivity in that first year.